Good morning, ladies and gentlemen. My name is Saud Ghani, and I work for Qatar University, and I work for Aspire, and I work for the Supreme Committee. So I've got many hats and many other special projects, especially when it comes to cooling. Cooling in hot areas is it's an art. It's like a black art. You are in this room sitting. Maybe some of you are comfortable and some of you are not because you are from different backgrounds, different genders. Some people having different type of clothing. Some people are near where we're disseminating or pushing air. Some people are far off or next to an extract. Unless you're an engineer, you wouldn't notice where is the air is coming from. But at the end of the day, I need two things. I need a generation side where I generate some cools, and I need a delivery side. You can get into your car and put your air conditioning on, and temperature is right, but you're not going to feel comfortable because, for example, the diffusers, which diffuses air to the car, are hitting your upper area. So your eyes will be a little bit itchy. You start to have some tears. Your breathing will be not in a good condition, although the temperature is right. Sometimes temperature is right, velocity is right, but the humidity is not right. You will feel muggy. You go into a space and it's cold, but at the same time it's muggy and stuffy because the humidity is high. So that's and humidity is the key whenever we started to work in cooling in areas, and that's why humidity is a measure of how quick any fluid can evaporate. When we cool ourselves, we use evaporative cooling. Our skin is our heat exchanger to the environment. Your sweat is the medium. It started to evaporate, and then after it starts to evaporate, it cools your body and core temperature. If the humidity is high, that ability of evaporization is breached. It would not be easy for the sweat to turn its phase from a liquid form into a vapor form. So the ability to absorb that extra heat that you're generating while you're doing an activities is not that efficient, and that's why more heat will be trapped into the body, and then it can go into a stress or a thermal stress, and then sometimes it can go to a full stroke. And we do that all the time. We monitor, especially in the 2022, we monitor our workers' ability to sweat and that sweat to evaporate, and that's why we use different indices. Our standard index that we use is something called WBGT, wet bulb globe temperature. Is different from a normal degree centigrade or a dry bulb temperature that you will be, for example, monitoring your patient. In your patient, you monitor a temperature. That temperature is a dry bulb temperature, is not a wet bulb temperature. So where's the page down? It's there. Yeah. Okay. So I've got 98 slides, so I'm not going to go through them all. But you know, high humidity. That's the problem where we work. Our environment is really harsh. In Qatar, is really harsh, especially in summer. Sometimes even in winter, if the humidity is high, that's a harsh environment to work with. So different indices. This one, for example, we've got the factors that will affect the human functionality, direct exposure to the sun, not enough fluids or breaks, high temperature, high humidity, all this, lack of sleep, all this we monitor it in the 2022, guys. I know that you can't see this, but there are a lot of thermal indices that we can use. There's something called Discomfort Index, and then you will find something called RH, which is relative humidity, is a factor. Cooling power index, so again you will find it is a function of the volume fraction of water, which is in the air. Humidex, and that's why it's humid. Humidex, so humid index. That's why you'll find relative humidity. WBGT is 0.7 of wet bulb temperature. This is where the temperature where it is easier for any liquid to evaporate, and we measure it. Maybe you will think of your days when you were in the high school, secondary school, when you have a thermometer and you put a little bit of a cold wick or wetted wick, and then you will see that its temperature is lower than the other thermometer, which reads a little bit higher because it reads the evaporation temperature of that wick. There's something called UTCI, so again you will find it's a function of relative humidity. Set is what we use indoor. All this you can use outdoor. Set we use indoor. This is called standard effective temperature. Function of your clothing, function of the speed and wet bulb temperature as well. And all these are what a description of these indices. So no risk, moderate risk, high risk, or extreme. The other one would say hot, mild, and cold. All this, every index have its own description of its own thermal risk. But you know how it is calculated. You have a formula to calculate. It's effective in a sport. That's the WBGT. So it's a good indicator of heat stress on the body, because about 0.7 of that index is the humidity. We have flag conditions. It tell you what to do in each one. And it's been adapted by IAAF as official, FIFA, NCAA, World Health Organization, ISO standards. All these are, it is the standard or official measurement of heat stress in all these bodies, and some of them, I think they will be related to yourselves. So, and that's what is WBGT. It's 0.7 of the wet bulb temperature. This is the ability of the liquid wick, the liquid from the wick to evaporate. 0.2 of dry bulb temperature. This is the higher than this. Plus 0.1 globe temperature, which is related to radiation. If you go to Qatar now, in the new Lafayette Center, you'll find that there is a cold walkway. I am guilty of designing that walkway. It doesn't work in the middle of the day. Why? Because of that 0.1 globe temperature. You have direct sunshine. Radiation is too much. So even when I control the wet bulb temperature and dry bulb temperature, if the radiation is too much, again, you would not feel comfortable. And I think you experience this every day. You drive your car, temperature is good, but if the sunshine coming from your left-hand side through the glass, you'll feel that your side is burning. Temperature is right, so why it is burning? Try to hold the steering wheel is really hot. It's more than 60, 70 degrees C if your car is parked in the sun. All this is because of the sun radiation, which is watt per meter square. So a different kind of energy that we cannot really take into account or counterweight that. So how we measure WBGT? Officials use a dry black ball. That black ball or sphere is black because blacks absorb more of the sun radiation, and at the same time convert that energy into our formula. This will measure the 0.1 globe. These two, one will measure the 0.7 dry bulb, a wet bulb, and the other one will measure the 0.2 wet bulb. That's the official device that most of the organizations they use. Is portable. One of their problem that it is a spot. For me, it's a spot temperature measurement. It's not global. So if you're talking about a field of play, or if you're talking about a track, the guy will walk and will take only a spot measurement. And that's one of the problems with these devices. Till now, there is no globe temperature measurement. It's the same as here. I will have like a thermocouple that measure the temperature in this room. It will be in a set point, wherever they set the temperature, or in your room where you set the temperature, you have only one spot measurement where that particular sensor is. We don't have a global in your office, for example. And this is the same. So if you talk about field of play, so again, it's a spot measurement. And that's why we tried in our innovation and in the legacy to have something I will show you later, which is under development, but it is working. So once you measure the temperature, you have 4 flags. You have the green flag. If your measurement, it's in degrees C, but it's not Celsius. It's a degree wet bulb globe because it's an index. It's not a physical phenomenon. It's that formula. So if a green flag, there is no risk. If you're a yellow flag, then risk level increase as the event progresses. If it's a red flag, everyone should be aware of the injury potential. Individual even break. Short breaks can be taken for water. If it is black flag, sometimes if it is more than 29 degree, then even there could be no match altogether. So these are the flags that internationally recognized for the thermal risk with the WBGT, and these are the activity guidelines per flag. So what we do, I think you are the master of this. From engineering point of view, I've got a fluid that I need to cool. I've got a heat exchanger I need to cool. So the more cold air, the more cold environment, because I need to transfer the heat trapped in this heat exchanger to the outside. To increase the heat trap, this heat transfer, I need to make delta T as high as possible. So this guy, if I have a cold bath, I'll just drop him in cold bath. And then, I don't know, 38 or 40 will be cooked, I think, to 0 or something like this. That's fine. For me, even if I can drop more, if I'm not going to damage the tissues. But this is the way that we look at it. Human bodies are heat exchanger for heat flow. If you increase delta T, the amount of heat flow will increase. So giving fluid for evaporization, and then cooling the guy by having this, what we call forced ventilation, to increase the amount of flow, because the amount of m dot, again, if it is increased, the heat exchange will enhance. Okay, so football. It was a challenge. I was involved with the bid before the 2022 being handed to Qatar. One of our challenges that we wanted to promise that we can work even in summertime. And I was involved in the previous designs and in the current designs to give the bid the scientific edge of convincing these guys that it is possible. So at the bidding stage, it was more of it as a presentation and some technical. But then when this guy pulled that piece of paper and said Qatar, we directly, immediately celebrated, but then we started. So we started with the stadiums, and I think every day you see this iconic stadium. When you design stadiums, and the stadium is an individual, is like any of us. Every one of the morning will come up in the front of the mirror, and then we'll put the nice clothes. Your taste is different from his taste, and all that sort of thing. But this iconic building will be there for about 100 years. So that's why it must be related to religion, culture. For example, the Al-Bayt is a culture, Gahfiya, this is the house, is a culture, or heritage, and then the requirements and the technology that we can promise with the weather. So stadiums, I think they never changed since the Romans. Place where people sit or stand, an area in the middle where people compete either for their lives or for a ball. It's still the same. So people even can use it for functions. If it is not looked after, this is the Marcana after the World Cup. No maintenance. So again, I can put very expensive kit that it will be very difficult for me to maintain it, and I don't want a white elephant like the Marcana. So I will skip through this. These are Al-Bayt, Rayyan, Thumama, Wakra now is called Janoob, Qatar Foundation, Khalifa, which is here. This is the Lusail, Abu Aboud. Each one of this have a different concept, because the height is different and everything is different. But the question that we always meet when we do a presentation now is being moved to winter. So why I'm doing cooling? That's a valid question, and we have a valid answer. So the surface area of a person's skin, or that heat exchanger, is about 1.8 meters square, roughly. That's our skin area, and we are emitting all the time heat, and that heat, typical laptop will give us about 50 watts when it works, 15 watts when it is off. So we're giving about 2 laptops of heat, 2.5 laptops of heat. That's an average person. If somebody's a little bit chunkier, can give about 4 laptops amount of heat. And if that is being contained, I may imagine a Lusail is 80,000 people, and multiply that by an average of 2, so that you have 160,000 laptops sitting, giving heat. Even in winter time, you need to make sure that you ventilate that and you take that heat away. So our concept is the thermal comfort, and how we can give the players and the spectators and the grass the good microclimate that people will enjoy. stadium in Khalifa. Then we further used it in the, I think the IAF championships, and I was one defending the Qatar bid. I think it was in Monaco about 3 years ago, because people were concerned about the amount of air, how it will affect the javelin and the rest of it. We were there at the time, Dahlan and Sheikh Saud on the bid. Maybe you recognize this guy. That's Abdulaziz Al Mahmoud. He's the deputy president. Design tools. This is the basic air conditioning concept. I have something called air handling unit. It will be somewhere outside. Khalifa Energy Center will give us a lot of chilled water. Chilled water will go here, and I will have a radiator. Radiator is like your car radiator. I'm pushing cold water. I will pull in cold air. This cold air then will go into ducts, and it comes through these what we call louvers, and it will go down to yourselves. And then I will have something called return in order to go back to the same treatment plant and then go back directly to people. I have to push all the time fresh air from outside because people breathe. The amount of CO2 will increase and the amount of O2 will reduce. So I have to make up air. The makeup air will have dust, will have a lot of muck. Sometimes you have birds, feathers, leaves, and it's high temperature. The return is a little bit cooler. Mix it in that box. If it's in a hospital like this, I think I was involved with the theater. So it was not only the amount of temperature that they want, even the amount of pressure they wanted into the theater. And I think that's why we have sealed doors, and we have to make sure that it's positively charged all the time in order to dissipate the air out, and there is no amount of return air. So a theater requirement will be different from a operating theater requirement will be different from any other requirement. So this is the basic concept. I have a place where I generate cold air, cold water. That cold water will be pushed through the system to yourselves, and that cold water will heat exchange itself with the amount of air, hot air is in the room, and then we go back. We use a lot of computational fluid dynamics. Before we used to use a lot of wind tunnels, but now we do our work in computational fluid dynamics. By the way, computational fluid dynamics, we can use it to simulate movement of air, movement of blood, cerebrospinal fluid flow, bypass surgeries, in your case, anything, any fluid, valves, heart valves, whatever. So any fluid that moves due to difference in pressure, due to heat, we can simulate. It's not only in a typical engineering, but in the biomedical as well. So this is a facility that you can use in the university. I was involved before with cerebrospinal fluid flow, LASIK operations as well. So all that I was involved from the biomedical side. Drug delivery for airways. This is the wind tunnel we use in the university. So we started with a small space called a SED. We've done the cooling on a SED. Because I'm aware of the time. This is, I just wanted to tell you that even the surface will be different. This is actual measurement in summertime in Khalifa before we demolished it first time to rebuild it. So the grass temperature would be around 35, 40. This is your running track, middle of the day. It can reach up to 70. Because the grass is a living organism, all the time is pulling air, pulling water, and then evaporates that water. So as a living area, is about what? Is about, if this is 35, this one is 70. So we've got about another 35 temperature difference only because of the surface. And because of the material, the material color. We looked at the grass and how the surface will change with temperature, what is the thermal capacity of the grass, because we wanted to make sure that the grass will have a good growing environment as well. We've done a lot of work in, it was I think if you look at this, this was in 2014 during the Brazil World Cup. We put people there and we put a lot of, this is the fan zone, Aspire fan zone, and then we put a lot of air from the side, and then we looked at what is the thermal comfort environment. So we've done survey every day during the match for people, and this is called predictive mean vote, and we ask about gender, nationality, background, age, and then we see if we can provide what is the best thermal model that we can use to reflect. And WBGT was the best even for people moving around. So these are the actual surveys we've done with the people. This is the way we looked at people. Is it better to deliver air from under the seat, or is it better to deliver air from top? Unfortunately, like in Khalifa, a lot of people say it's really cold because I have a small control. Khalifa is an old stadium. We couldn't go and deliver air under the seat because the slabs were very small. I just wanted to show you this is even, we have thermal printers in the university. So we put small people, and we even maintain the core temperature in a thermal environment, and we looked at how the body, what is the difference between core temperature to head temperature to feet temperature. So these guys, they have inside them we put some heat generators to look at about the amount of air flow we do. We do laser printing as well, or these are the models we do. In the university we do wind tunnel analysis. So I just wanted to show you what I mean by the measurement. This is a thermal imager for the study. So where you have the cross is that temperature. So that person core temperature about 35.5, while the environment was 37, and we're pushing a lot of cold air on these people sitting in the stand. And we try to understand, is it better to deliver air under the seat, or is it better to deliver the air from top? And what is the thermal comfort for these guys? We've done that in the university. We delivered then even the amount of air. This is a bait stadium. Everyone under their seat will have a structure like this. That structure, if you can see, is not uniform. So these opening for the nozzles to deliver the amount of air, and it is opening with an angle, and in the middle one to give you a swirl to make sure that we have enough nice gentle breeze around the people to take that humidity away. So even we designed our own delivery side, and this is how we can behave. We looked at the tiers. What is the difference between upper tier and lower tier for people sitting high up, or people seated lower down? We looked at facades and how these facades will trap the amount of heat because of the solar radiation. We change these facades. I want just to tell you this, and then we conclude because I'm aware of the time. WBGT and set temperature is used to be till now measured by this device. It's a point measurement. So what we've done, I will just go and bring a figure quickly here. It's this figure. So what we've done is we used a thermal imaging camera to get a thermal image, and then we devised our own correlations between our measurement devices within the vicinity, and then we mapped the temperature to be the set or WBGT. So I have a correlation here for me, and the correlation will give me and map of this is our weather station, the wet bulb globe temperature, which is about 5 or 6 of them in the stadium, and this one will give me the air velocity, wet bulb temperature, and dry bulb temperature. I will take that through a Wi-Fi to my computer, and then through the thermal image for the same area, then I will put in the computer my if you like algorithm that will map this and pixelize it over this one is not the set, but it is the dry bulb temperature, and then you will have this either wet globe temperature or a set temperature. So now you'll have a global picture, depends on your angle, zoom angle of the thermal imaging camera. This one is a patented technology. We didn't patent it yet. We tried this in the last Amiri Cup with actual measurement.
and we used artificial intelligence for the system to train itself all the time and make sure that the error, and I think the error now, we managed to bring it down within 0.1%. So now we'll have a global measurement rather than an individual measurement of WBGT. And I think the guys, the upper management, they like this technology, and they wanted to put it as part of, they will propose it to FIFA as part of the new improvement coming as legacy from the next 2022. So with that, I think I will, this is actually the image. So that's the original image map. That's our inputs. You can either put it manually or through the system. This one is the overlaying, and this is your WBT values would be directly shown into your device, and it is global measurement rather than a single point measurement. I think this is part of the code. So, and last thing we've done, I think, is coming here, and then I will let you go. We've done the thermal helmet for workers. Now we've got about 8,000 helmets within the workers. So it's got a solar cell. We pull the air from the back. It goes to the front of the worker, and at the same time, I have a PCM pouch inside. The PCM is phase-changing material. It's like a wax, paraffin wax. So the amount of heat coming from the air will pass on that pouch, and then that pouch will start to melt and turn. I think when the temperature is about 28 degrees C, that's the melting point temperature. And that pouch we calculated that, and it is now even in the field. We've done the analysis for it. It takes a worker working fully during the summer in the sun 4 hours, because we calculated that 4 hours, because they can then go for a break, lunch break or coffee break, and then back again. And all what they need to do is to take that pouch out and put a new pouch. And if you are outside, it's charged by the solar. Inside, even we have a USB socket. You can charge that battery. It's a patent. This patent, I think, now belongs to Aspire, and we already have 8,000 pieces on the market. We have a lot of interest, even from Emirates and Korea, UK. There is a firm now. They do windmills, because they have the workers go inside the windmills blades, and they feel hot. They tried that one, and they like it. I mean, a lot of people outside Qatar now, they're using this one. So with that, I'll be happy to take any questions.